and sharing my screen. And going to start by opening OneNotes. We started looking at polynomials last class. Today we're going to continue to look at polynomials and operations on polynomials. And we might have time to start looking at factoring. Homework P3 is the one that deals with radicals. That's not due until the 8th. Some of those questions are going to be on this quiz, though. This quiz is going to include simplifying exponential equations. It's going to include simplifying radicals. And in simplifying radicals, it's going to also include rationalizing denominators. So it's going to be that stuff from questions 1 through 19 in P3, plus the stuff that was in P2. That quiz will be open after class today until Sunday late. The quiz is in my math lab, but again, is everybody listening? You must submit work in Blackboard. You hit work in Blackboard. If you have a question wrong, I can give you credit. Flip side, if you do not put work in Blackboard, you will not receive full credit. The quiz has 10 questions. Right now, it's about 30 minutes. If somebody filled in the paperwork with the accessibility office, they have additional time. Otherwise, if you're afraid you're going to run out of time, do the best you can to get answers in Blackboard and put the rest of your stuff on the paper that will be, I'm sorry, to get your answers in my labs and put the rest on the paper in Blackboard. Does anybody have questions about any of those? Does anybody want me to go into Blackboard and in Blackboard go into my labs? Does anybody want to look at any of the questions from any of the homework problems in my labs? Does anybody want to go over anything from any homework? Have I waited long enough? No questions? Can you guys hear me?
Yes.
Not that I can think of.
Okay. If there are no questions, something that I forgot to say, if anybody was using that 14-day free trial, that temporary access, hopefully when your access ran out, you were able to purchase an access code. If you have not yet done so, I am begging you to please stay after class and talk to me or get a hold of me so that we can come up with something for you to use until you get that access. I can give you paper copies of the homework and I can give you paper copies of the quiz. But again, if you're doing it that way, you don't get the infinite do-overs or the help functions. And you do have to email those back to me by the due dates. So, any questions on anything? If not, why is this not liking me? If not, we're going to go ahead then and remember that a polynomial is the sum of many terms. And we want to put them in descending order, which means the exponents go down as we look at it from left to right. I believe that was where we left off last class. When we look at a polynomial, sometimes we talk about something that's called the leading coefficient. And the leading coefficient is the coefficient on the highest degree term, or on the first term after it's in descending order. So let's say, for example, I have x squared minus 3x cubed plus 4x to the 5th minus 2. And I want to know what's the leading coefficient. And I do believe that there are some questions in the homework that ask you just that. In order to do that, we need to first put it in descending order. And so, in descending order, can anybody help me with which term would come first?
4.
The 4x to the 5th, because that's my highest exponent. Then my next highest exponent would be on the 3x to the 3rd. Then I'm going to put a plus in front of it because it's positive x squared minus 2. And so here my leading coefficient is 4. Beautiful. We also talk about the degree of a polynomial. And the degree of a polynomial is the degree of its highest degree term. And so again, this is also easiest to determine if we're already in descending order, because in descending order, we have those exponents go down. And so can everybody see that this example would be 5th degree? And so let's look at a couple other examples. Let's say we have the polynomial 9x squared plus 6x minus 5x to the 6th plus 2. And I want you to put it in descending order. I want you to tell me the leading coefficient. I want you to tell me the degree. And I want you to tell me the constant term. And I'll give you guys, folks, a minute or two in which to do all of that for me, please. Descending order. Anybody want to tell me what you got?
9, 6. Is it already in descending order?
No, because I wanted to go down by exponents.
Oof.
So highest exponent is 6, so negative 5x to the 6th. And descending order means I want the full term, not just the coefficients. Then next highest exponent is the x squared. Then the x to the 1st. And then the 2 has no variable.
Does it always go by exponents?
Yes.
Okay.
Descending order is always by exponents. Long time ago in this class, we learned long division. And it's important when you do things like long division and when you do things like factoring, it becomes easier if it's in order by exponents. And so that's just the norm in terms of polynomials. Leading coefficient?
Negative 5.
5.
Degree?
Negative.
degree has to do with the exponents. So we're going to say 6. And the constant term is the plain old number, the constant at the end, 2.
The constant term will always be the number that's just by itself.
Right. And if there is no number without a variable, then your constant would be 0, right? Nothing.
Okay.
Okay. Now let's look at another example. Let's look at 2x to the 1/2 plus 3x to the -1st plus 5. And that's a tricky one. Does everybody notice that this one we can't do because it's not a polynomial? We said in order to be a polynomial that it had to have natural number exponents. I'm sorry, I lied. It had to have whole number exponents. And so here we have a fractional exponent and a negative exponent. So this one's not a polynomial. And so we're not going to use those terms in describing it. All right. So this idea of descending order means the exponents go down. Once it's in descending order, the leading coefficient is on the lead, means it's the first one in the beginning. We can also just think of it as the coefficient on the highest degree term. The degree of the polynomial is that highest degree, that highest exponent. If I have more than one variable, for the degree, we have to add the exponents on the variables in a given term. Next page, I think, is going to be familiar territory to most of you. It's the idea that we classify polynomials by the number of terms. And so first we'll have a monomial. And is everybody familiar with the idea that like mono, like if somebody wears a monocle or something like that, it means one. And so a monomial has one term. So an example of a monomial, just a single term, variables and constants with whole number exponents held together by multiplication, something like 15x squared y z cubed. That's a single term because they're all being multiplied. How about a binomial? Any ideas to what a binomial has?
2.
2 terms. And so it'll be 2 terms that are being added or subtracted. So an example might be something like that a squared minus b squared. This is one term, this is another. They're connected by addition or subtraction. Trinomial?
3.
3 terms, beautiful. And we're going to spend a bit of time looking at trinomials, especially factoring trinomials. And an example might be something like x squared plus 2x plus 1, where I have 3 distinct terms. Other than that, anything bigger than that will be considered just a polynomial. And every once in a while, you might see something that's an expression for a general polynomial. And when I talk about a general polynomial, I don't want to necessarily say how many terms there are or what the degree is. If I'm leaving it general, I'm going to have a variable for the degree and for the number of terms. So I might start with x to some power. I'm leaving a space in front for a reason. Then the next one would be the power 1 less. I'm leaving that space for a reason. And each time the exponents are going to go down by 1 until finally I get x to the first and then a constant term. Because I don't want to say in particular what the coefficients are, and I don't want to just use different letters of the alphabet because there's nothing that's saying we have to restrict our thinking to 26 possible terms. So I'm going to call each of those coefficients A. But they're not all the same, so I'm going to use a subscript so that A sub n would be the coefficient on x sub n, a sub n minus 1, a sub n minus 2. This would be a sub 1, and then my constant term would be considered a sub 0. So the a's are our coefficients. And we notice that the exponents on the variables decrease. And I think with something like this, sometimes when people see something like that, they kind of say, what the heck is going on? And I'm just trying to leave it real general. I don't know how many terms that I have. We're considering it to be in descending order, and each coefficient is different. The subscript just tells me, okay, I want to use the letter A to represent them, but they're not necessarily all the same. So far, so good. Then I'm going to turn the page, and we're going to start looking at operations on polynomials. And the first operation that we're going to consider is addition. And it's a concept that we've already used several times during the course of the semester. In order to add polynomials, we're going to just combine like terms. And again, like terms, we said have to have the same variables with the same exponents. So, simplest example, if I have 3x squared plus 4x squared, what would my sum be?
Seven x squared.
Beautiful, 7x squared. And so next example, if I have in parentheses negative 7x to the third plus 6x squared minus 11x plus 3, and I want to add to it the 19x cubed minus 11x squared plus 7x minus 17.
Jeez.
Again, we have to decide what are like terms. Technically, order of operations, you're supposed to do what's in parentheses first, but neither set of parentheses can we combine anything because they are not like. So theoretically, we can picture a 1 being in front of the parentheses, and when we distribute the 1, it doesn't change that. So then we can go ahead and look at using our commutative and associative properties to rearrange them. This next line you don't have to write, but I'm going to write so that people know what I'm talking about. Those are both x cubed, so I'm going to take negative 7x cubed plus 19x cubed, they're like terms, and get 12x cubed. Next, this is x squared, this is x squared, so I'm going to take 6x squared and negative 11x squared, and those will combine to give me negative 5x squared. Then I'm going to take the first degree terms, the negative 11x plus, oh, I'm sorry, I wrote that in the wrong place. Sorry about that, guys. The negative 11x plus 7x. And when I combine those, I'll get negative 4x. And then lastly, I'll add the 3 and the negative 17 to get negative 14. Again, you don't need to rewrite them with the like terms next to each other, but if it keeps you from making careless mistakes, by all means, feel comfortable doing that. I'm going to throw up one more example, and I'm going to ask you folks to try this one. This one, again, is going to be a little bit more challenging. Let's look at negative 2x squared y plus xy squared plus 4yx squared plus 7xy squared plus 2xy. Then I'm going to shut up for a minute and ask you folks to consider that one. Have I waited long enough, or do you folks want another minute?
Another minute.
I'm sorry, I could not understand what you said. Another minute, or are we good?
Another minute.
Okay, thank you. We okay? What I think makes this one tricky, in the binomial, I have negative 2x squared y. In the trinomial, I have 4yx squared. Does everybody recognize that those two are like because they have the same variables with the same exponents? So when I add their coefficients, negative 2 plus positive 4 would give me 2. And I'm going to write it as x squared. Why? Because it's most common to write them in alphabetical order. X1s, I have x squared y and 7x squared y. They're like terms. I'm sorry, I misspoke. That's xy squared and 7xy squared. They're like terms, so they'll both be xy squared. When we add the one from the binomial to the one from the trinomial, hopefully everybody recognized that there's an invisible coefficient of 1. So we get 8xy squared. And then this last one doesn't have a like term, but it doesn't mean we're going to ignore it. It just stays as an addend at the back. How'd you guys do? Not hearing anything. Next, we're going to look at subtraction. And in order to add subtraction, I liken it to when I first learned how to subtract with assigned numbers. I was told that we're going to define subtraction as adding the opposite. So for example, has everybody seen if I have 3 minus -4, we think of that as 3, change the subtraction to the addition and add the opposite. When we do this with polynomials, we're going to think of distributing a -1 to the terms of the polynomial behind the subtraction. And I think we did a little bit of this when we were looking at that idea of simplifying expressions earlier on. So let's say, for example, I have a binomial x minus 2. And from that, I want to subtract another binomial, 3x minus 5. Most people do it on that line, but I'm going to rewrite it so that everybody knows the difference between the original question and what I wrote. I'm going to think of this as I'm going to distribute the -1 and then think of adding it. And so distributing -1, that second one becomes -3x plus 5. And that's where a lot of careless mistakes occur. Please, please, please make sure you remember to distribute that -1 to every term in the parentheses. And then what's in front stays the same. I'm adding those. So 1x plus -3x would be -2x. -2 plus 5 would be +3. So let's have you folks try one of these. A little bit more involved, but the same general idea. Let's say I have 18x to the 4th minus 2x to the 3rd minus 7x plus 8 minus, in parentheses, 9x to the 4th minus 6x to the 3rd minus 5x to the 2nd plus 7. And I'm going to be quiet for a couple minutes and ask you folks to try this. You guys ready?
Yeah.
So I'm going to think of putting that 1 in front, which will change this into 18x to the 4th minus 2x to the 3rd minus 7x plus 8. Then distributing the -1 would be minus 9x to the 4th plus 6x to the third plus 5x to the second minus 7. I can combine the x to the fourth terms. 18 minus 9 is 9. I can combine the x cubed terms. Negative 2 plus 6 is positive 4. Those aren't like. Keeping it in descending order, I only have one x squared term. I only have one x the first term. And then lastly, the 8 minus the 7 would be plus 1 at the end. How'd you do?
Yeah, fine.
Okay.
Yeah, I got it.
You got it?
Yeah.
Okay, great. Then if we're okay with addition and subtraction, because again, that was something that we were doing when we were just simplifying expressions, the next place that we're going to go is multiplication of polynomials. And here life gets a little bit more involved. Because how we multiply depends on the size of the polynomial. First, we're going to look at if I have a monomial being multiplied by a monomial. And that's a single term multiplied by a single term. And so here what we'll do is we'll multiply the coefficients and we'll use our exponent rules on the variable parts. Whoops. And I think we've looked at problems like this before when we were developing those rules for exponents. If I have, for example, 6xy to the fourth, and I'm multiplying it by 12x to the third, y to the second. First, we have to take the 6 and multiply it by the 12, which would give me 72. And then does everybody remember when I multiply common bases, I add exponents. But over here, where I have the x without an exponent, does everybody remember there's an invisible exponent of 1? So x times x to the third would be x to the fourth. And then when I multiply the base of y to the fourth times y to the second would be y to the sixth. Is that something that everyone is comfortable with? Is that close enough to what we did with the exponent section?
Yep.
And next is to take a monomial and multiply it by a polynomial. And here there's one word that we've used repeatedly through the semester that's going to apply, and that's the idea of distribute. And then once we distribute, what we'll do is we'll have several products of two monomials. And so, for example, if I have, let's say, 8x times in parentheses x squared plus 3x minus 4, just for this first one, I'm going to write a middle step out. Most people do this middle step in their head, but conceptually what we're doing when we distribute is we're going to take that 8x and multiply it by the x squared. Then we're going to add that 8x times the 3x, and then we're going to use the operation there, subtract that 8x times the 4. And so we've turned it into 3 products of monomials, which will then give me 8x to the 3rd plus here 24x times x would be x squared minus here 8 times 4 is 32x. And again, if you can go from the original problem distributing to the final answer, I'm fine. But if seeing that middle step worked out keeps you from making careless mistakes, by all means do it. So let's have you folks try one of these. Let's look at negative 2xy squared times x minus 2y plus 7. How did I do? Did anybody else get negative 2x squared y squared plus 4xy cubed minus 14xy squared?
Yep.
Great. And if those are all right, the next type of multiplication, please bear with me. I know there are 3 different ways that it can be taught, that you might have seen any one of the 3 in a previous experience. So I want to make sure we go over all of them. Next, we're going to look at multiplying a binomial by a binomial. And one way that it could be taught that you might have seen is the idea of repeated distribution. I know that somewhere along the lines in math circles, there was an era where any silly word to help you remember things was frowned upon, and they wanted everything to go back to definition. And so this was the method that multiplication was taught. So let's say, for example, I have a plus b times c plus d. First, I'll distribute the a times the c plus d, and then I'll add to it distributing the b times the c plus d. So I guess technically first we took the c plus d and distributed over the first binomial, and then distributing again, I get a times c plus a times d plus b times c plus b times d. And is there anybody who in the past multiplying 2 terms by 2 terms distributed twice each time? Another way to go from that original problem to their final answer was, has anybody heard of FOIL? When I
Way
look
back in the day.
Yeah, that's the way it used to always be taught. The F stands for the first in each binomial. The O stands for the outer, the terms that are on the edges of the problem. The I stands for the inner, the terms that are in the middle of the problem. And the L stands for the last in each binomial. So if I have A plus B times C plus D, when I talk about the first in each binomial, that would be the A times the C. Plus, when I talk about the outer, I mean the ones on the outside edges, that would give me the A times the D. Then I, when I talk about the inner, it's the two in the middle. That's BC. And then L, the last, would be the last one from each binomial, which would give me the BD. And please notice that those two methods give us the same result. And then the next method is one that I taught in my math for education majors. And recently I've had more students tell me that this was how they learned it. And that's the box method, where I kind of try to find areas of different regions. And so I picture a box, a rectangle. One side has lengths A plus B. The other side has length C plus D. And so we're going to divide it. So this is length A, this is length B. This is length C, this is length D. And so the area of this first little rectangle would be A times C. The area of this second little rectangle would be B times C. The area of this third little rectangle would be A times D. And the area of this last little rectangle would be B times D. And then we take the sum of those to get our AC plus AD plus BC plus BD. And again, it gives me the exact same terms. I guess it's just another way of organizing those pairs that I get when I use my FOIL, or another way of organizing those products that I get when I distribute twice. They all work. Has everybody seen at least one of those?
Yes.
Because they all take you to the same place. To me, it doesn't matter which one you use, as long as you use it correctly. So I'm not going to say you must FOIL. I'm not going to say you must distribute twice. I'm not going to say you must box. Use whatever you're most comfortable with, but make sure you use it correctly. So for example, I'm going to look at x plus 8 times x plus 5. And we can either distribute twice. We can think of it as x times x plus 5 plus 8 times x plus 5. Or we can first outer, inner, last. Or we can box it. Either way, and I have to tell you, I'm a FOILer from way back when. So I'm going to FOIL. First is x squared. Outer is 5x. Inner is 8x. Last is 40. And then sometimes we're able to combine like terms to get x squared plus 13x plus 40. And again, I would have gotten those same 4 terms if I distribute it, or if instead of writing them horizontally, I put them each in their own little box. Next example. I'm going to give you folks a minute to try on your own. I want to look at x plus 2y times 3x minus 4y. And could you folks please multiply that out and let me know what you got? Is there anybody else who got 3x squared plus 2xy minus 8y squared?
Yep.
Yeah.
Does anybody want me to add details in between, or is that one all right?
Can you add details?
Sure. In terms of adding details, which method are you most comfortable with? Box, FOIL, or distribution?
Distribution.
Okay, so I've got x plus 2y times 3x minus 4y. First, we're going to take the x times the 3x minus 4y. Then we're going to take the positive 2y times 3x minus 4y. So far, so good?
Yeah.
Now distributing x times 3x is 3x squared. X times minus 4y is minus 4xy. Again, you could have written that product in a different order, but it's most normal to put the coefficient first and the variables in alphabetical order. Then here, positive 2y times 3xy. Let's see, 2 times 3 is 6. And then letters in order, x times y. And then the positive 2y times the negative 4y would give me negative 8y squared. And now a lot of times those middle two are like terms. Here they are, so I'll combine them. I'll keep my 3x squared. I'll keep my minus 8y squared. But in the middle, they're like terms. I'm going to keep the xy. Negative 4 plus 6 is positive 2. Better?
Yeah, thank you.
Okay. Next one's kind of interesting. Next one, I want to look at x plus 6 times x minus 6. And again, I'm going to shut up and ask you folks to try this one on your own for a minute. Can I go over yet?
Yeah, I hit a snag.
Okay. With this one, are you a FOIL, a box, or a distribution?
I think I'm not really sure. Somewhere between foil and distribution.
Okay, let's
Either one of
FOIL
those.
this one. First, outer, inner, last. The first would be the first ones in each. So that's x squared. The outer would be the ones that are on the edges, the outside. that gives me minus 6x. The inner are the middle ones, the ones right next to each other. That's positive 6x. And the last are the last ones in each binomial. So that gives me negative 36. And if you distribute it, you get those same 4 terms. And if you box, you get those same 4 terms. What makes this one interesting is, do you notice in the middle, if I take negative 6x plus 6x, well, negative 6 plus 6 is 0. And so I'm left with x squared minus 36. And this is
That was my,
Go ahead.
wasn't sure what to do with the x when it equals 0.
If I have 0x, well, if I multiply anything by 0, it's 0, and I don't need to show it. And we're going to, this is what's considered a special case that we've made use of already when we rationalized in our denominators. What we did there with the x plus 6 and the x minus 6, if I were to write that as a plus b times a minus b, that product would always be a squared outer minus ab inner plus ab last minus b squared. And those middle terms will always be opposites and add to 0. So that'll always give me the first one squared minus the second one squared. And isn't that what we did when we multiplied something by its conjugate? And so this one, if you can remember it, is a shortcut. If we take the product of a sum and difference of the same terms, let's say I have y plus 2z and y minus 2z. Do you see how the terms in each binomial are the same? Just one's addition and one's subtraction. It will always equal the difference of the squares. So it'll always equal the first term squared minus the second term squared, or this would be y squared minus 4z squared without doing the extra one. If I have 2y minus 5 times 2y plus 5, I have one's addition, one's subtraction. They both have the same terms. Again, this will always multiply to the first one squared minus the second one squared. Or if you can go without writing that middle term, if I square 2y, I'd get 4y squared minus, if I square 5, I get 25. And that's a pretty nifty little shortcut that you can use. So using the shortcut, could I ask everybody to please multiply? Oh, let's say I have xy minus 10 times xy plus 10. Hopefully with this one, everybody realized the first terms are the same. The second terms are the same. One's a plus, one's a minus. So it'll be the first term squared. And when I square xy, I get x squared y squared. It'll always be the difference. And then the second term squared. When I square 10, I get 100. Is that one all right? Can I put a smiley face?
Yep.
If so, we know how to multiply one term times one term. We know how to multiply one term times many terms. And we've got a couple of shortcuts if we're multiplying a binomial times a binomial. Beyond that, if I'm going to multiply a general polynomial by a polynomial bigger than 2 by 2, we're going to find that there really isn't a shortcut. And what we need to do is we need to use our repeated distribution. And combine like terms. So for my first example, let's say I have y minus 2 times, let's say I have y squared plus 3y minus 5. Notice the first one's a binomial, but the second one is not. The second one's a trinomial. Over here, I have more than 2 terms. Because I have more than 2 terms there, I've got to distribute. And I'm going to distribute twice because I'm starting with the binomial. First, I'll take that y, that first term, and multiply it by the trinomial, y squared plus 3y minus 5. And then after I multiply everything by the y, I have to multiply everything in the second polynomial by the negative 2. And now I've got a single term times many, so I need to distribute again. Y times y squared would give me y cubed. Y times positive 3y would be positive 3y squared. Y times negative 5 would be negative 5y. And then negative 2 times y squared would be negative 2y squared. Negative 2 times positive 3y would be negative 6y. And lastly, negative 2 times negative 5 would be plus 10. And then I'm going to look and say, oh, wait a minute, I got some like terms here. There's only one y to the third. Combining 3y squared minus 2y squared, I get positive 1y squared. Combining negative 5y and negative 6y, I get negative 11y. And then I just have that one constant plus 10. I've distributed twice. Not gonna lie. Another way of writing that has the same effect. Multiplying each term of the trinomial by each term of the binomial. But I just think it's a more, I like writing it this way better, probably because it's the way that I learned. If I were to look at that same product, y minus 2 times y squared plus 3y minus 5, I want to write it one underneath the other, y squared plus 3y minus 5, because it's the longer one, I'll put it on top, and y minus 2 underneath. And then I liken it to the way I learned how to multiply multi-digit numbers. First, I'm going to multiply everything by the negative 2. Negative 2 times 5 is positive 10. Negative 2 times 6y, I'm sorry, negative 2 times 3y is negative 6y. Negative 2 times y squared is negative 2y squared. Then I'm going to go through and multiply everything by the y. Y times 5 is 5y. And I'm going to try to line up my terms so that like terms are in a column. Y times positive 3y is positive 3y squared. Y times y squared is y cubed. And then when I add down, I'll be combining my like terms. Hello, I have to apologize, guys. I made a sign error here. This was -5. And you see, it takes us to the exact same result. We're doing the exact same multiplication and addition. It's just written differently. Which is the better way to go? The one that you're more comfortable with. So I'm going to ask you folks to please multiply. And this one's a neat one. We're going to take x plus 5 and multiply it by x squared minus 5x plus 25. And I'm going to give you folks a minute to do that one. Are you folks ready to go over yet, or do you want me to keep on waiting?
I think I got it.
Would I go over it? I rather write it up and down or sideways?
Sideways.
Sideways. So we'll take the x times the x squared minus the 5x plus the 25. And then we'll take the positive 5 times that same thing. So far, so good? Distributing the x would give me x cubed minus 5x squared plus 25x. Distributing the 5 would give me positive 5x squared minus 25x plus 125. So I've got that single x cubed, negative 5x squared plus 5x squared. There's opposites, they add to 0. No need to show them. Positive 25x plus negative 25x also adds to 0. They're opposites. And so I'm just left with x cubed plus 125. How fun is that? Something so big, bad, and ugly multiply so concisely. So, where it becomes a little bit more involved, where you have to be careful is, can I turn the page?
Sure.
Is if you raise a polynomial to a power. Here we have to do our repeated distribution. If you're on the math train long enough to get to pre-calc, and pre-calculus, you'll learn a shortcut, but it involves all sorts of notation that we don't have under our belts. So we're going to just have to multiply. What do I mean? Let's say, for example, I have something like x plus 2 to the third. Here, this is not a single term, so I'm not using just my exponent rules. This means that I'm taking that binomial and multiplying it by itself 3 times. I can't do that all at once. So first, I'm going to FOIL or box or distribute to multiply the first 2. Multiplying the first 2 would give me x squared plus 2x plus 2x plus 4, or x squared plus 4x plus 4. But I'm not done yet. I still have to multiply that all by that third x plus 2. So I'm going to have to take my x squared times x plus 2. I'm going to have to take my 4x times x plus 2. I'm going to have to take my 4 times x plus 2. This first product gives me x cubed plus 2x squared. This second product gives me 4x squared plus 8x. This third product gives me 4x plus 8. So I get, that's my only x cubed. These combine to 6x squared. These combine to 12x. And then I have the 8 at the back. And so if I've got a binomial or larger in parentheses, we don't have a shortcut. We have to multiply the first 2 and then take that product and multiply it by the third. And if I had it to the 4th power, I'd have to just keep on going and going and going. If I had it to the 5th power, I'd be multiplying 5 of them, and so on, and so on, and so on. So let's have you folks try one. Let's have you folks take x minus 3 and raise it to the 3rd power. And I'll help you by writing it out that you remember you need to multiply that thing by itself 3 times. How are you folks doing? Are you still working or are you done?
Still working.
Okay, I'll wait a minute. I'm just looking at the clock and I guess we're supposed to end at 45. So I'm going to just go over this real quickly. If you've got the answer, x cubed minus 9x squared plus 27x minus 27, you're good to go. Just stick around, please, if you need to talk to me about my labs access or if you came late. If you're unsure as to where that came from, I'm going to go over it real quickly. Multiplying the first two, I'm going to FOIL. First, x times x is x squared. Outer, x times minus 3 is minus 3x. Inner, minus 3 times x is minus 3x plus 9. And then I'm going to multiply it by x minus 3. Here, those will combine to x squared minus 6x plus 9. And again, I still have to multiply that by my x minus 3. Distributing, I'm going to take the x squared times the x minus 3. I'm going to take the minus 6 times the x minus 3. I'm going to take the plus 9 times the x minus 3. Distributing again, I get x cubed minus 3x squared. And distribution is such fun, I get to do it again. Minus 6x, watch your signs, plus 18. And then lastly, plus 9x minus 3. This is my only x cubed. Negative 3x squared minus 6x squared gives me my 9x squared. Oh, I apologize. I lost an x. 18x plus 9x is 27x. And oh, Lord, 9 times 3 is 27. And I have to apologize, folks. Those are the mistakes I make when I rush. So please don't you guys rush when you do your homework. Outside of those careless mistakes, how is it now? I'm going to stop sharing, stop recording.